Okay, hello everyone. Good morning, good afternoon. Welcome to today's webinar. This is the second webinar in the 2021 ICOS OTC pCO2 intercomparison series. The main goal of today's webinar is to summarize the results of the exercise, which took place at the Flanders Marine Institute in Ostend in Belgium over the last couple of weeks, and also to determine our path forward. As usual, Artur and I are going to be the moderators of this webinar. We will start the webinar with a presentation from Rik Wanninkhof, followed by a short Q&A session. And then later on, Tobias Steinhoff, Thanos Gritalis, and the team will present the preliminary results of the intercomparison. And now Artur will go through a couple of housekeeping items. Please, Artur.
Yes, thanks, Dasha, and welcome everyone. So just a few housekeeping notes. We will be asking you to post your questions during the presentations for the questions box, and then we will answer all those that we can live during the question and answer session. There'll be a brief one after Rik's talk with any relevant questions to his presentation, and then a longer session towards the end. The webinar will be recorded, so for those colleagues of yours who are not able to join us because of time zone issues or otherwise unavailability, we will make the recordings of this webinar as well as the previous one available online in a few weeks. You will receive an information about that. And I think that's it in terms of housekeeping, so I'll let Dasha introduce Rik. Thank you.
Yeah, thanks, Artur. So without further delay, I'd like to introduce our first speaker, Rik Wanninkhof, who doesn't really need an introduction, at least for those for the CO2 community. Rik Wanninkhof is a oceanographer at the Atlantic Division of Oceanographic Meteorological Lab in Miami, Florida, at NOAA. He studies the oceanic inorganic carbon cycle and has done extensive work on the surface measurements of pCO2 and used the measurements to study the transfer of carbon dioxide across the air-sea interface. Rik's today talk is how we will use the information from the intercomparison exercise. Please, Rik.
Yes, good day, everyone. I hope you can hear me. Dariia, just wave your hand if you can. Oh, you're gone. All right, thank you. Yes, in some ways, this today's seminar is sort of, backwards, is that I'll be discussing how we'll use the information without the audience knowing what the information is about, which is actually the highlight of this presentation given by Tobias. But I was asked to give this presentation sort of with a bit of an historical perspective. I've managed not to actually be present at any of the intercomparison studies which have been done to date, starting in 1991, but I've been peripherally involved in all of them. And one of the things that I've noted that all the previous experiments have been a tremendous success, have advanced the field a lot, and this one will do the same, I'm sure. But a limitation of some of the previous studies have been that not all information really got into our, what I like to call, into our psyche. Some things seem to sort of, be brought forth over and over again, and so I think we have a real opportunity in this study, in the way that this study was set up, to get the information out to the people who want it and need it. So what I'll describe is a little bit how this experiment was fairly unique, that there was quite a bit of near real-time remote input to this actual intercomparison. And I show on this map the locations of some of the participants who attended these daily meetings, which were at 3 in the afternoon in Ostend. And I particularly would like to give credit for those who are in the dark or the zones going dark. A lot of people got up at non-working hours to attend these informational sessions. Next slide. So every day at 3 o'clock Ostend time, we got zoomed into the headquarters of activity and got the folks who did actually do the work on the screen, and we spend the next hour and a half each day discussing the study and the next progress. Next slide. And this was greatly aided that early in each morning, the data, the preliminary data, crossed the English Channel to Jutta Schuster at Exeter, who did a really nice job of doing preliminary plots, which we then discussed to make some assessments on, how to do the following studies and how to make adjustments. Next slide. And this is sort of a screenshot of one of the armchair experimentalists, trying to make sense out of these plots. As you'll hear, this study was sort of unsurpassed scope with close to 30 different instruments which were maintained, and so the comparisons were exciting and challenging. But having this real-time data or near real-time data and being able to address issues and adjusting, I think, have done a great, really helped improve the overall study. Next slide. So, but besides discussing sort of preliminary results and how adjustments to do, there was a lot of discussion on how will we use this information, and I think this foresight is critical for the overall success of this study. And I could have covered several pages of this. This is a smattering of things which came up, and I will just sort of touch. I won't read all this up, but I'll just sort of touch on those that are in bold. And one of the things that came up over and over again is what the community really needs is how does this performance in the comparison translate to real world conditions. Also, this issue is, and I'll bring this up later on as well, is how does a user use this information to select the best sensor for their purpose. Another thing which, and this is, was highlighted as the accuracy of the support sensors are critical for calculation and diagnostics, and in particular temperature and pressure. Without the temperature and pressure, we cannot determine the proper CO2 levels in the analyzer. There is also a bit of a lament that we don't have the right instrument specifications, and it's in part because we never really have written a manual what is required. And then one thing that really struck me is that within this intercomparison, there was a really close interaction with the manufacturers of the instruments who were, many of them were present at these daily meetings, and also if they were not present, some of the super users of the instruments were there, which were very helpful. And also, if we want to continue in this field, want to grow this field, where I see that we'll probably have a 2 order of magnitude increase in sensors in order to address the problems that we hope to address, we need to support commercial suppliers. And so I think one of the highlights to me is that what we have to do with this information is help the community in selecting the right instrument for its intended purpose. Next slide. So this is sort of an example of providing meaningful instrument specification, and it's very generic. But on the left-hand side is a manufacturer instrument specification blurb from a pamphlet, which seemingly gives useful information. But on the right-hand side is sort of information that is required for efforts like SOCAT, and in this case, I believe this is a quality information document for ICOS. And if I don't want to scrutinize it, but you'll see that there are some obvious and some subtle differences in what is really required for the user to select the right instrument for their purpose. Next slide. Then I think a really important thing, and it was, at least for me, that served as a take-home message for me and this comparison, is we need instruments that are fit for purpose. There are a wide range of studies that require, surface water CO2 information, and we don't all need the Cadillac of CO2 systems. It's like in real world, everybody doesn't need or want a Cadillac. So we have to sort of appreciate that. And so on the left-hand side is one of the important application of surface water CO2 measurements is determining the global air-sea pCO2 difference in order to estimate the air-sea CO2 flux. And this is a zonal average from a climatology of pCO2, sort of illustrating what sort of the annual averages are from 80 south to 80 north. What this shows is that we need to know, in order to tackle the global air-sea CO2 flux issue, we need to have accurate instruments that can measure relatively small differences. On the right hand side is a plot of what you can see in an active coral reef of CO2, and here we're looking at different scales. On the left is a global climatological average, on the right is daily changes, where our range is from 200 to 1,000, and I would not say that you'd use the same instrument for either application. But importantly, in order to make the selection of the instrument, we need to know how good our instruments are, and which was brought up frequently in our daily discussions, we have to define what good is. And I say the community has to define this and document this. Next slide. So one of the take-home messages we sort of had in our informal discussions, what I took away is that the full utility of this in comparison will realize if we openly disseminate the data, the results and the interpretations thereof, we capture and store all information from the exercise, provide clear recommendations and take-home messages, and make such work integral to our observational schemes, particularly for networks and for assessing quality of correlated databases. Next slide. And this is sort of an example of sort of the way a pretty rough sketch of sort of what terms we like to use, our value chains. What has been performed in the last 2 weeks is a really good intercomparison of some instruments and checks of a unified data reduction scheme. And this information will feed to improved field deployments, assessment and interpretation, data QC, data reduction, and then move into the depositories. You can see that sort of the large feedback loop, and there will be feedbacks in every step, but the large feedback loop in the comparison, as I see it, is towards instrument builders and documentation of instruments that in turn will basically feed into improved quality of our data sets. Next slide. Oh, hold on. Could you go back for a second? Also, a bit of advertising. This part of the value chain is we've worked on this over many years and under sort of different organizations, but I think this is really going to improve a lot. We sort of started with this idea of getting sort of a separate entity under, we got a catchy acronym SOCONET, which IOCCP was very involved with, but now it looks like we have got traction within the G7 Economic Forum that has a component of Futures of Seas of Oceans, the Futures of Seas and Oceans Initiative, and it looks like we will get, it's very promising that there will be support from the G7 going to IOCCP to strengthen this this component of our value chain. Next slide. And the value chain that we are really working on is a slide which was provided by Dorothee Bakker, modified from some other cartoons. But we are basically in the bottom of the pyramid with our observations, and then and so the bottom rung is where we hope we can make great advances with hopefully with some G7 logistics support start, and then it goes on all the way up to the global societal problems that we're hoping to address under aegis of the United Nations framework of Convention on Climate Change and the Ocean Decade for Sustainable Oceans. Next slide. So what I would sort of summarize is, and you'll hear a lot more detail, is that the Ostend pCO2 comparison was more sensors than we ever done before in an intercomparison study. I was very impressed with, even with preliminary data, how a lot of these sensors have really improved. Most of the manufacturers have been, working on these instruments for quite a few years, and they're improving substantially, and they want to work with the users to continue these improvements, and there is an awful lot of information. And I think basically this intercomparison should be a critical continuation of an ongoing dialogue to improve our surface water CO2 observations. And I cannot thank the folks who were in Ostend for the last 2 weeks enough. And luckily, the weather for our purposes cooperated. If you look at the Ostend tourist information website, you can basically have a to-do, what you do in nice weather and when the weather is not so good. And thank heavens the weather was not so good at the seaside resorts, so that our experimentalists on site did a fantastic job in executing this experiment. Thank you.
Thank you, Rik. I see no questions in the box, so please do not forget to type your questions. You can do it while the team from Ostend is going to be presenting, and we hope that we can answer them at the end of the presentation when we have a large Q&A session. Okay, so and our second and I think most important presentation today is why everyone is gathered, is presentation by Tobias Steinhoff, Thanos Gritsalis, and the entire intercomparison team in Ostend, and they will show us the preliminary results of the intercomparison. Please.
Yes, thank you, Dasha. Now I have to again manage to share my screen. Do you see our presentation? Yes, thumbs up. Very good. Yeah, first of all, thank you everyone for joining again, and thank you, Rik, for your thoughts and words for this intercomparison. I think maybe one step back, don't expect too much of results during this talk, because as it's clear, we just closed down and packed everything. So we will show some very preliminary data, which might give you an idea of what we will work on, not we here, but the whole group that participated in this exercise in the next weeks and months. Okay, here you see the whole team that was involved, or most of the people who were involved in the preparation of this exercise. Some only, quote unquote, only in the preparation, and the names in bold with underlines. These were the people who were actually here and running the exercise. A little bit. The ones who were at the first webinar might remember the slide, but I think it's a nice entry to the whole exercise. Why did we actually do it? It comes from the ICOS Oceans Network, which is a heterogeneous network consisting of more than 20 stations, which is very mixed between ship of opportunities in the coastal and in the open ocean, fixed ocean stations at the coastal and the open ocean. And all the stations use different instrumentation, and also new sensors come on the market. We want to use them, but of course we have to know how do they perform. And the final question for us is, how comparable are the measurements for within the ICOS Oceans Network? And this can be translated, of course, in the global context. So this was the beginning reason why ICOS even decided to think about an pCO2 instrumentation in the comparison. So why we did it, I will not go through all the points again, but when we were planning the whole experiment, we really had we try to focus on what can we do for the science, what is the scientific question for an exercise like this, what is the need of the observational community, what does the observational community really need, and what is the need of the instrument manufacturers. So we really try to have all the 3 points in the mind while designing the whole experiment, and we hope that at some point at least we succeeded, but these points might need to get revisited after we have a closer look into the data and reconvene with the whole group. Just a short history. See, I shortened this very much. The first planning started already in 2018. In May 2019, we came up with concrete plans. So we wanted to do the exercise in August, September 2020. We plan to have up to 30 participants with their instruments here on site and run the experiment and discuss the findings directly here on site and have the knowledge and the time to change things, to make instruments better. And we want to allow for 1 week of setting up period here in Ostend. Then came Corona and somehow changed everything. So we postponed the intercomparison to 2021, so the date stayed. But at some point we had to see that we will not get anyone coming here. So we decided to do the whole intercomparison with just a core group which was part of the whole organization group. Even of this group, some people had to bail out because they couldn't even travel within Europe. So just a month before the actual intercomparison started, we were down to 3 people running the intercomparison, but luckily we could win with 2 young people here just short before the intercomparison to jump in without really knowing where they were signing up for and helping us to make this happen here in Ostend. So we had 29 instruments and 20 to 30 participants joining virtual every day at our daily meetings to discuss with us the measurements, the findings, and the way forward. So we really, even if there were only a few people here, we tried very hard to make this whole thing a community effort so that that we can deliver the best results out of this intercomparison for the whole observational community. Again, intercomparison at a glance. In the upper figure, you see the facility here in Ostend, and we were located here in this warehouse in a smaller container, and there was a tank in there. You will see more pictures in a second. And it's Ostend is somewhere located here. It's a small strip of the Belgian coast at the North Sea. So in the preparation of the whole intercomparison, we were building groups around each instrument. We tried to bring together users and vendors to think already before we actually deploy the first instrument here, to think about how is the best way to deploy it, what do we have to do, think about calibrations that have to happen before, and so on and so on. So we asked every group to provide we call it a quick start guide, which should be, of course, every system or most of the systems come with a manual, but we wanted to have a 1, 2, 3 page long checklist that an educated user could use or should use to deploy the instrumentation successfully. So we had this quick start guide here. We were, of course, focusing only on surface applications in a facility like that. We planned for different pCO2 levels at different temperatures, and we ran it for nearly 2 weeks to really allow time for adjustments so that we could put in findings that we had during the day immediately into action and maybe see what they do. And again, we were using a 5 cubic meter tank, this natural seawater from the North Sea. The advantage of this was also that we could exchange the water in a very short time. So how did we do? We divided all the instruments into 3 groups. Of course, there's a lot of overlap. So we had so-called surface instruments that normally are installed on buoys or surface vehicles. We have submersible instruments that are installed on moorings, and we have underway instruments that are classically installed on ship opportunity lines or research vessels or something like this. As we said, or as I said, we compared 29 instruments, and there were 18 different types. So we had 7 instruments from the surface group, 9 instruments from the submersible group, and 13 underway instruments. So during the experiment, or also of course in the future, all groups had access to the raw data as soon as we got them from the instruments and their of their own instruments, and of course to all auxiliary data like temperature and salinity. And we documented the work on site in Google Docs, so that in the beginning it didn't work that fast, but we got better with time, so that we really could somehow have a lab book that is always up to date, and if people looked in their own data, in their own raw data, to see what was going on, they could have an idea of what we did or what we didn't do. This is how we try to run it. So these are all the instruments. On the left-hand side, the table, all the underway instruments. It's an AFT sensor from Sunburst, 3 flow-through systems for Jena, from Acontros, 1 from German University, 1 system from FLIS here for Tanos. We had 2 GO systems, 1 with a new LICOR 7815 and 1 with the classical 7000 LICOR. We had 1 underway Proceanos installation. We had 3 instruments from Subsea, 2 times the Cube and 1 time the race system that is installed on this racing sailboats, and 1 super CO2 system. From the buoy or surface type instruments, we had 1 ASV, 1 MAP CO2. We had 2 systems from the Vegas, 1 buoy version and 1 wave glider version. We had 1 sensor from MKE, Carioca, and 1 Capassos from the University of Exeter. And for the submersibles, we had the 3 Hydro Seas for Jena, from Acontros, 1 instrument from Tokyo University, 3 from Proceanos, and 2 SAMIs. So this was a whole suite of instruments that we deployed in or at the water. The whole data processing, as Rik mentioned, we used, for most of the instruments, we used Quints. It's an online tool for data processing, developed at the OTC. Actually, we have to say, without Quints, we wouldn't have been able to present the data in such a short time frame. It was really, we were coming here in the morning, downloading or extracting data from the instrument, and Steve and with help from others, we're sitting there the whole morning, pressing the data through this online tool, so that Ute could get it in time to make the plots for the daily meetings. And in addition, of course, we asked all PIs to do their own data processing, so that we could compare the output from Quints with the output from the data from the PIs, who of course know their instruments best. And already there we could figure out some problems with Quints. So Quints really learned a lot over the last 2 weeks. Okay, so setting up period. So we started here actually on the 16th of June with the first. Tanos and this group here at FLIS already did some work before, but in the 16th of June we really started to set it up. Again, we used 1 5 cubic meter tank. It was connected to a heat exchanger, nothing else. This was the only thing it was connected to, so that we could regulate the temperature in the tank. We distributed 5 calibrated temperature sensors throughout the tank, so that we could also check for its homogeneity. I never wanted to say this word again. We had 1 connectivity sensor, so that we had a measure for salinity. And for the underway systems, we had a submersible pump that fed all flow-through systems. We had 6 reference gases calibrated by the ICOS calibration lab, which is traceable to WMO. And they were ranging from 0 gas, and then 150 was the lowest non-zero reference gas, up to 800 ppm CO2. As I said, we had natural seawater, and this could be exchanged within 2 hours. So we also proved that. Took us 2 hours. The pCO2 in the tank was adjusted by adding acid or base. So we just use HCl and sodium hydroxide. This was a sketch where we were trying to figure out how we place the instruments and how to connect them. You don't need to understand everything, but just this was a pump, even if it's not a technical drawing, and this were the 3 branches of water that we connected the instruments to. We had one pressure regulating valve so that we had always a constant pressure for all the systems, even if one system got turned on or off or whatever. And a little bit more complex drawing is for the gas distribution system. This was, as I mentioned before, a pretty mind-blowing exercise, but we figured out that this was actually the easy part. To get this construction tight took 2 people 2 days, but they managed. This was a clean overview how we wanted to install everything. Here you see the tank, and around it placed all the underway instruments. The submersibles are not in the facility, and maybe pictures tell more than a drawing. So this was a tank facility before we came here. On the left-hand side, you see the black tank. It has some infrastructure here which we did not use. It was aerators and filters, so we did not use it. So the tank was really separated from all the rest here. And then we started to populating it. We put in stage elements because we had to come high enough that all the underway systems could drain by gravity. Here you see Thanos looking skeptical on the tables. And these were our gas bottles hidden behind the big wall. And these were the assembly of black boxes. I would say something like half of the instruments came in black boxes, which was already a challenge to know who is who, but we found a good system to label everything. Just some more pictures on the left-hand side. We're already nearly done with the setup. You see only the underway instruments here. 2 happy people posing with an instrument, and here you get kind of an idea how it was looking in the tank. It was hard to get a really good picture from the tank, but it was a lot of hoses and metal frames and ropes going in and out in the tank, and but we managed to keep the overview who is who. I will not go through all the numbers, no worries. This is just a sketch that we made from the tank, looking on top of it. Only thing I want to mention, the 16 years, this is where the water came back from the heat exchanger into the tank. We had a pipe going all the way down to the tank so that the water got distributed very fast throughout the tank. And this triangle, these were our 4 temperature sensors, SBE38s. 2 of them were placed approximately 30 to 40 centimeter water depths, and the other 2 a little bit deeper at 1 meter 30 water depths that we also used to monitor how homogeneous our tank is. And at the 18 and 6, this is where the submersible pump set together with the SBE37 for temperature and salinity. So the whole tank diameter is something like 2.5 meters. So it's really not a big tank. Then the intercomparison itself. This is just a sketch from the whole time period. So you see here, 28th of June to the 9th of July. And what you see here is just all the temperatures from the 5 temperature sensors. And you see here in the beginning, this little spot here, which caused a little heart attack for me, but it was just that we forgot to replace 1 temperature sensor after we put in an instrument. So we have a very precise air temperature measurement here for 1 day. So the first days we didn't change the temperature. This plus this up and down is just a regulation from the heat exchanger. We left the pCO2 stable. This was actually our warm start, so to say, of the intercomparison. And then we started to change the temperature, going down to 10 degrees. And over the course of the experiment, we made our way up to 30. And then at the end, we came back to the nearly starting conditions. So as I said, we use the temperature as a proxy for mixing. The temperature sensors in the tank agreed well to most of the time within 0.02 degrees. And this is not true for the times of active cooling or heating, because then, of course, the noise was a little bit bigger. And the warming between the tank and the flow-through instruments was on the order of 0.2 degrees Celsius. And maybe one sketch from the last day, because we had, of course, a big discussion how homogeneous is the water in the tank. You just see a very short time period from something like 6 o'clock in the evening until 6:30. There we see all the temperature sensors are together here. And here we put in 5 liters of hot water to see how fast this is mixed into the tank. But they were close here at the beginning, and here at the end they were close together again. Okay, now to the actual measure we were interested in, to the pCO2. Here you see the pCO2 of the whole timeline, again from the 28th of June to the 9th of July. And as I said before, in the beginning, we didn't do anything to the tank. We just tried to get all the systems running and measuring reliably what they saw. And then now you see part of the signal is just due to the temperature that we changed, in part, especially the sharp gradients, when we added acid or base. This is, so to say, the overall pattern, what we covered in the whole experiment. And as Rik mentioned, we discussed our findings in daily meetings. So every morning we gathered all the data from nearly all instruments, processed them using Quints, and in this meetings we discussed then the latest findings, some troubleshooting ideas, some adjustments, and even discussed error sources to agree as a group. What do we see here? What are our ideas for maybe divergences or for big strange signals we saw? And then we tried to go back and take the ideas from the meeting back to the tank facility and apply the ideas and see what this meant. After this meeting, so in between today, we also, of course, had smaller groups meetings with just instrument-specific details where we discussed the experts for the specific instruments. So for the next plots, just to mention, so we chose one instrument as our reference system so that we had an idea of what we are comparing to. The discussion of a reference system, I will not go into the detail here, but we agreed now to use this one system, at least for the course of the first comparison here, and this needs to be discussed further detail in the coming weeks. Here you see just one screenshot from our daily meeting, and we used this Excel sheet here to a little bit then plan forward our different pCO2 levels, water temperatures, and different air temperatures. Even if there's water still written here, it was the air. And during these meetings, we looked at plots like that Ute prepared every day, and she really put a lot of effort in meeting everyone's needs in terms of coloring and symbol size. So all these plots also made a big development over the course of the whole exercise, but you can also imagine comparing 29 instruments is a little bit challenging on one plot. So we had then at the end different plots for different groups of instruments. And what you see here, I really want to note this, it's really very preliminary data, and further processing needs to happen to them. So there are some of the data we have to understand why are they so different. For some of the data we already understood and did some changes, and maybe this is my next my second next example. This is just one other way how we looked at the plots. This is also just a short time. It's from something like 4 o'clock to 6:30, so it's a 2.5 hour time window where we zoomed into specific situations that we wanted to look at. And here on the top you see the water temperature during the time period increasing a little bit. You see the air temperature being rather constant. you see the air CO2, and you see the absolute CO2 values here on the upper right plot. And the main plot is the difference between our chosen reference and a specific instrument. So we don't show any names here because this would be anyway too busy to see anything. But this was the plots that we're looking at. Where do we see differences? Do the differences depend on temperature, on pressures, on whatever? So we really try to have a close look and a big discussion around what can cause this difference, and then we could go back and yeah, check if some of the ideas were true or not. This is just one example. This is the same set of instruments that we compared here, and you see here in black the reference system, and in red and blue the other two systems, and they were a clear offset. So this was an easy example. It was just a data processing problem, but also this helps in fixing this problem. Then the next day or a different day, it looked like that. So these were things we could already fix here on site, and I think this is also a very nice and good outcome of this exercise here. For the next plots, I don't want to go into big details, but if we look at the pCO2, because this is the main measure we always compared, I mean, we need to know the xCO2 and the pressure, at least for equilibrator-based systems. And then for the temperature correction, we use this Takahashi correction, which includes that we have to know our temperature in the tank and the temperature at equilibration. So somehow there's three things that going in there: xCO2, pressure at equilibration, and temperature at equilibration. And this is just one example out of a lot. This was one instrument where we saw a big offset in the pCO2, more or less constant. But when we compared the xCO2, they fit very well. So the problem here for this instrument was just a miscalibrated, or for a long time not calibrated equilibrator temperature element. And then when we applied the correction to the equilibrator temperature, then also, of course, the pCO2 fit way better. So it's just a reminder already here. Temperature is a critical measure in the whole pCO2 calculations and processing. So it's very important that we have the temperatures precise during the whole measurement system, from the water body we want to measure and from the water that we measure at our instrument. Another example was pressure. So here, if the pressure is measured accurately, so on the top you see pressure readings in the equilibrator from two different systems, and on the bottom you see the reported or calculated pCO2 from these two systems. And you see on top that the system here, denoted in black, had some obvious problems with the pressure readings. So it was fine until it wasn't, and then it stayed there until it came back here again. So this looked for blockages in the equilibrator bands, and luckily this doesn't have a big effect on the calculated pCO2 as long as we know the pressure in the system. This might be okay, but of course we don't want a blockage of the equilibrator vent all the time, because it can also have then different effects. Air can be drawn from somewhere else or whatever, and we can get a faulty measurement later. And one side effect where we started to look at, this is not really thought to the end yet, but due to the sharp pCO2 increases or decreases that we induced by adding base or acid, we could a little bit look at equilibrator response times. So you see some equilibrator-based systems on the top and some membrane-based systems on the bottom. So there might be some information in this data set to even say something about response times of different systems. But again, this is all preliminary data, and the more data you see here, this means the more work is there to do for us to now really go in the details and analyze the data. Just a few more pictures. This was a tank from above. Here you see all the ropes and hoses. On the right-hand side, you see Thanos pouring in some acid. I think it was our first acid step, where we still had to adjust our procedures, but we got better and better. And on the bottom, you just see a panorama picture. Here is the tank superstructure that you see here. And these are all the underway systems from back here, all distributed over the whole facility and here on the table. So the outcome, okay, the outcome, this might be a very strong word at this time, but maybe just some first preliminary ideas and our plan how to proceed. Because we really see this, that what we finished on Friday/Saturday was really just the practical part. So real work is now coming and involves a lot of people and a lot of work to really look carefully at the data. And this is what we planned tentatively. So we scheduled already a next meeting in September. We as a group, not only this group sitting here, but all the people, PIs who participated with the instrumentation, want to come together again. And until then, we want to have a clear data sharing policy, because we think the whole exercise will benefit if we share all our data freely. Already during the post-processing period, we expect everyone that the data processing is finished by then, and the data processing should happen in a transparent and public way. So it should be for everyone should be able to take the raw data and process them in the same way as the PI is doing that, so that you get the same result. Everyone has to be able, if we start with a millivolt, we have to come to the same pCO2 value at the end. And of course, we want to also use this again to improve the Quints tool so that this can be reliably used also in the future for other instrumentations. We have to revise the quick start guides, because now, of course, the quick start guides were very helpful for us, since we now had to set up all the instruments ourselves. Some instruments we know or knew very well, some we didn't, so it was very helpful to have the quick start guides. But of course, we also found a lot of missing information that could have been helpful to have in the quick start guide or in the manual, and we noted this, and we will replace this back to the manufacturer so that this can be improved for the future. These are very often it's just little things, and I think it's very clear that someone who designs an instrument doesn't have every single thing in mind, because it's so clear for them. But for us as users, some more information sometimes would have been very helpful. Yeah, and this whole data processing, of course, is a back and forth game, because then we have to come together, compare our data, see where they agree, see where they don't agree, and then find out why don't they agree, and maybe also to what kind of level. This is maybe what Rik already brought up. What is the purpose of the instrument? Do we expect a little shoe carton sized sensor perform as well and as great as a half wall covering installation? This also, of course, needs to be communicated. And then there are some dots and a lot of free space, but we want to really publish the results with all names, and all data will be made freely available to everyone. We're a little bit hesitant to put a hard deadline on it, but the plan is to publish this as soon as possible. Smaller than a decade. So here, just some immediate important and not so important findings. They are really super preliminary and very subjective. Rik started with more the bigger picture. Here we come a little bit from the part where we just our impressions or my impressions from the last two weeks. One thing all the way on the top, calibrate your temperature sensors. This is not a new finding. I think even Arne mentioned this in his talk 2 weeks ago from an intercomparison from 94, 96, but long time ago, so they already figured that out. We can just say there were still instruments with a not well calibrated equilibrator temperature sensor, and this should be done at home in the lab. This can't be done easily in the field. We tried our best to find a little correction ideas to that, but this has to be really done by the PIs or by the manufacturers or whoever is responsible to deliver this instrument to the field. It's definitely clear that we need a repeat exercise, and this is now our proposal in less than a decade with a larger core team. And the next one is more a citation from one of our meetings. It is essential that users know how to install the instrument correctly. And actually, this is exactly what we thought way before we started coming here during the whole preparation phase. This was the idea for the quick start guide. It can't be that the users just get an instrument and go ahead and measure. So we need input from the manufacturer, but the same works the other way around. Also, the users, the scientists, they have to understand what they are doing there. They have to understand what can my instrument do and what does it need. So I also have to pay attention to the manufacturer's guides, how to install and how to run an instrument. This is sounds very clear, but we think it's a very important outcome here. Another thing that came up in the discussions in the last weeks, so we need a transparent and honest error calculation or error propagation for each instrument for the final pCO2. This, how to get there depends, of course, on each instrument, but this should be done, and we will aim for that we have a fair and honest error calculation for each instrument, and this should go beyond the initial factory determinations. So we aim to provide specific recommendations to the manufacturers and users. This goes a little bit back to the quick start guide, and what they can do to reduce the spread for the next intercomparison, or it's best already for tomorrow when deploying the sensor in the field. Now, very subjective and in this whole context, stupid comment: if manufacturers provide lab cables, make them 2 meters longer. This makes everyone's life easier. And even if you're sitting only with one instrument in the lab, it can't hurt to have a 3 meter long cable instead of a 1 meter long cable. It would have made our life a bit easier. And then another citation, which maybe brings up a very important point, I don't want to say most important point, maybe this is the most important point. A high quality measurement is one where the uncertainty is appropriate for the scientific question being asked. And I highlighted the word uncertainty, which also comes back to the error calculation. We have to think about the uncertainty that an instrument can do and the uncertainty of the application that we want to use it. I mean, Rik showed also this plot with this high daily amplitude. Maybe we don't need to know the difference between 100 microatmospheres and 1000 microatmospheres in a day on plus minus 2 microatmospheres. Maybe different instruments are better for applications like this. But this should be discussed and outlined, and this is definitely on our agenda for the next weeks and months when we work up all our data. And of course, there are a lot of more findings out of this intercomparison, but to put them out there, they might need some additional source before we can write them up. But these are things that will definitely show up in the publication that we plan in a more readable way. And this actually brings me more or less to the end of this presentation. So you see, we even found some time for art. So it's a little bit the reminder of our switch lock installation, and this is a leftover of the whole host installations, the sad picture from yesterday. no, from Saturday. And then I only can thank you, ICOS OTC and the Research Council of Norway, to provide us with the financial resources to actually do this exercise here. I want to say thank you to Liz, who hosted this whole exercise. It was a very fantastic place to do it. We got a lot of support from the local people here. It was a good place to have the whole tank area. We somehow took over half of their recreation area and made it into an office. Was nice to be here. Thank you, Liz. Thank you, IOCCP, for organizing this webinars and already support us during the preparation phase. This was really helpful. Very much appreciated your bigger view on this picture. Of course, I want to thank the organization group that over 2 years met every month and later even more often. It was Thanos, Craig, Ute, Emil. Emil wrote over 2 years every month very nicely the minutes of the meetings. Steve, Melissa, Claire, Dasha, and Maciek from IOCCP. Special thanks to Craig and Ute, who supported this exercise behind the screens. I think Craig even turned around his whole day, so he got up when we got up here in Belgium to be available for us during our daytime, our working hours. So Craig always went to bed when his rooster started making noise. And yeah, as you heard several times, Ute provided us with the plots, so she was waiting in the morning that Steve sent her the first process data to start making the plots, and she really tried hard to meet everyone's wishes in terms of colors, symbols, or presentation methods. We actually came to a point that we could say that a different color will the results not make worse or better. Then, of course, thank you to the core team. So here you see all of us in a happy mood. First of all, Hannelore and Silke, the local technicians here at FLIS, who helped us with measurements of nutrients, inorganic, carbon, and alkalinity, and with anything you could think you need from a chemistry lab. They were always there, and of course, helping with the whole installation, having even fun during the help. I want to thank Vlad and Emma, who really jumped in here last minute and not knowing, as I said, what they have to expect. Also for us, it was hard to describe what they can expect. We only told them, nice people, a lot of work. And maybe it looks unfair that I put this picture here, but this was one of the few moments where both of them were sitting. Otherwise, they were just running around and doing what they could do to make this happen here. I want to thank Steve. He really was every morning sitting in his cubby hole there and making the data and getting playback from Ute that something is wrong. And then he looked again into it and tried to get the data out in time. And last but not least, our host, Thanos, who is actually the master of finding things. What did we say? He's unlimited now. But unlimited resources, yeah. Whenever we needed a little plug or a cable or a metal piece to mount the sensor, he disappeared for 5 minutes and came back. And in the meantime, he had time to clean the tank when we changed the water and gave a little interview for the VLIS channel, which you can go on the VLIS website and find it. It's a very nice introduction to what we did here. And last but not least, of course, thank you to all the people who really came every day, even at the weekends. And as Rik already pointed out, from all crazy time zones to help us to make this whole comparison, well, hopefully a success, but they definitely helped us to make it better than we could have done only with us here. So thank you for your interest. And I guess you only can say, stay tuned. There's more to come.
Very good. Thank you, Tobias. I think on behalf of the PIs and sensor manufacturers who participated in this exercise, I'd like to express our gratitude in this work you've been doing, pushing the pCO2 measurements forward to something better. Yeah, so thanks again. There is a couple of, not quite some questions, so I think we can fill in the next half an hour with Q&A session. And if you don't mind, I will start with the tricky question from Rik. He's asking, what would you do different in the next experiment?
Nothing, no.
I don't know. I would bundle it together with probably what Andrew, one of Andrew's question on targeting this ±2 microatmospheres. That is the.
I'll just read the question for everyone. The SOCAT quality target for the best underway measurements of pCO2 is an accuracy of ±2 microatmosphere. What difficulties were introduced by looking to design an intercomparison exercise that allowed comparisons relative to such challenging target?
My personal feeling that one of the major challenges for this is to have as true of a reference as possible. That for me is crucial. Our decision was quite educated to use a reference system. It is quite well documented, but still, that doesn't mean that this system cannot be improved, or that this system might not be away from this target. So having something that is absolutely, or having a quite strong confidence, or a confidence level, that the reference is a reference, a golden reference, if you want to put it, I think it's quite important. That was something that it was very difficult to achieve with the means that we had so far. Maybe it's something that we need to build upon. That's definitely going to help, I think.
And maybe in addition, maybe it's worth to think about, do we want to design an experiment that suits every single sensor we can think of, or is the next comparison better suited to think about, I want to compare underway applications, I want to compare moored submersible applications, and I want to compare buoy type systems.
And we also need to acknowledge that the design was not specifically targeting this ±2 microatmospheres, because to an extent, we know in the community what can achieve this target. The design that follows the SOP published by Sabine Dixon et al. Is the one that predominantly provides this margin. One of the reasons of this comparison was to see the rest of the equipment that is in the market or coming, whether they can fall into this band. And that was also that it probably we are attempting to answer the three points from Andrew with what we're saying right now. Hope it's
yeah. So another question from Andrew that Thomas is referring to is, what were the difficulties inherent in dealing with so many classes of instruments, surface, submersible, underway, at the same time?
We knew the limitations of the setup. We didn't try to hide it. And that will be taken into consideration when we do the rest of the data analysis. But that needs to, by definition, this will be taken into account and see whether those kind of any limitations that might present to those systems have an effect on the systems themselves. The setup itself was not without challenges, but we believe that it was as representative for the majority of the sensors as possible.
Thanks, Tanis. There is a question about suitability of this exercise for many of the deployments. So Bronte Tilbrook is asking, the experiment was lasted for 2 weeks. Will there be an attempt to make recommendations for long-term deployments, which may impact the usefulness of an instrument to address the question?
I mean, of course, our only goal could be to compare the instruments under the controlled conditions that we have here. I think for some instruments you might be able to make an educated guess how they will perform in real life. For some this we might not have the means to say that. So we just talked in the lunch break about that maybe the outcome of this exercise is also that we might want to have a longer, I mean, really a longer term in the comparison, where you moor systems together. I mean, I don't want to design it now, but where you compare them really over a month or two under real conditions. But of course, this also has to be done very carefully, because at the end, I mean, we already had discussions here about how homogeneous is the water in the tank, what is with this, what is with that. Under that controlled conditions that we had here, so many external factors were discussed. We tried to address them as good as we could. But now translating this into the open ocean, then yes, I mean, if the one sensor hangs 1 meter further to the right than the other one, and there's an eddy coming through that only touches one and not the other, then the sensor measures different water. I mean, it has to be very well designed.
Yeah, and the logistics of this, of such a potential endeavor, are far from trivial. Finding the right platform to do it, willingness of the participants to engage for that period of time. It was challenging, as Tobias said, with the controlled conditions in a small tank. In the real world, it's highly desirable, but I think it will need 2 years, can easily be 4 in terms of the planning, if not more.
Okay, thank you both. I guess the question that I'm reading it now, the same question, it says, will there be an attempt to make recommendations for long-term deployments based on this exercise? And what do you think you would include into these recommendations, and whether they will differ from the ones we will make as a result of the 2-week exercise?
I find it a little bit hard to say right now what recommendations we can make at the end, but we definitely aim for translating our findings in as many recommendations we can surely give based on the experience we had here. And I think there are some that will be very valid. For example, calibrate your temperature sensors. It doesn't matter if you do it in a tank or in the field, but there might some that we can only make a guess or make an educated recommendation. Or yeah, we definitely will try to make this results and discuss this in the PI group. I think this is maybe the biggest strength of this intercomparison, that we are all sitting around one table and everyone is willing to talk about all the results. That helps us to get the most out of the data that we have here.
Okay, thank you. It's a technical question. Hello team, thanks for all this tremendous activity. How and did you manage to determine the lengths of each sensor water supply line?
I have the feeling the setup itself determined the length. It wasn't specifically designed, to be frankly honest with you. If that refers I mean, if that goes back to response time. But we've seen, for example, that the flow that we provided to the sensors and the proximity of the sensors to each other probably will not, something will come up in the post-processing of the data, if there is anything, but more than likely, and we will address that, but we believe that the effect of any long distances, if you want to put it like that, are probably going to be minimized by the actual response time of the sensor itself. It will not be a determining factor in the data reduction, or processing, but it's definitely something that we will take into account.
But it also plays into the story with how ideal was the setup, and I think in terms of that, of course, it was ideal. I mean, the instruments were as close as possible to the pump, which you will not have in a lot of real-world conditions.
I mean, we if you want to put it on a technical level again, the amount of warming, which is probably the most determining factor in a length of a tube, for example, for an underway system, was far less than what the majority of the systems in SOCAT are seeing. Even under high differential conditions between seawater temperature and room temperature.
Thank you. And I have just a comment from Rik. Besides more large intercomparisons, we should also encourage smaller side-by-side at sea intercomparisons. These should follow agreed upon protocols and data capture, and perhaps establish a repository of such ad hoc efforts. Would you like to comment on that, on the validity of such exercises and need for them?
I mean, I guess Rik mentioned the critical part on agreed protocols. I mean, I think definitely we as a community can only win from every piece of information that we can get from the real world. So if someone puts two different instruments on the same ship, for example, and compares the results, this is a very, very, very important information. But of course, it has to be made sure that these instruments are run in such shape, or such protocol has followed to make the data even comparable. Yeah, I mean documentation and metadata, sorry, are, I guess, the metadata, maybe the word to say here. They really have to be complete and sufficient.
I would say that this is something that the ICOS Oceans Network can foster to a small scale. We have the capacity and the interaction with the PIs to do something like that, but we might know if something like that is not happening right as we speak right now. It's down to the whoever is doing such a thing to actually report it, publish it, and make the information available. And crucial thing is the metadata, indeed, which is something that I'm going to be advertising ICOS right now. It's something that ICOS is and I think highly SOCAT. To be frankly honest with you, a lot of things were built up on SOCAT and the previous efforts. Let's not forget that. This is crucial, and the more strict the metadata regime is, the better your chances are to document or your chances are to be able to identify any uncertainty. That's something that PIs should not forget. One other take-home message from what we've seen so far is that users should be aware that plug-and-play instruments do not exist. Plug and pray, probably. Plug and play do not exist. All of them need a lot of effort. It might not be coming into the setup, for example, as Tobias said, a shoebox system might but it will need a lot of attention in the data processing. So there is something in the line of any system in the whole data life cycle that will need a lot of attention from a user. And that's something that users need to identify. They need to put the hours in. The numbers will not come magically.
Very true.
We found that out. A lot of people know that already. It cannot be stressed enough from what we've seen this last 2-3 weeks.
I think that's a very good point, Thomas. There is a comment here. I think that to have a good comparison, you need at least 3 sensor manufacturers.
We had 4 or 5, I think.
I think there's a, I think there was a comment about the smaller scale inter-comparisons, I guess.
Yeah, but again, anything that can identify inherent differences between systems might help. And maybe, for example, it might even help on a procedural level. For example, one has good metadata, the other one doesn't. And all these things are pieces of the puzzle that need to come together to identify that you need all this information in order to have a high quality data point. Which high quality doesn't mean it's extremely accurate. I think the high quality, we should emphasize on the uncertainty.
It's a defined uncertainty. It's a clearly defined uncertainty that the user knows what they can expect.
Okay, thank you. I don't see any more questions. If you guys want to comment on something or Ostend.
Just want to comment and yeah, an extreme thank you to Tobias and the core team. Yeah, we've embarked on this journey 2-3 years ago, and yeah, we as when we were both serving as chairs on the MSA to serve the community, basically. He's done a sterling job. Amazing. I'm speechless, actually, to be frank with you. Many thanks to you. Thanks for putting our trust on Vliz. Thanks to the guys of Vlad and Emma for joining at the last minute. One more thing, there's one person that we didn't, we kind of forgot, is Dieter, electronics technician, who helped us a couple of days and helped us troubleshoot a couple of things. But yeah, it was a fantastic experience. I'd really like to thank Tobias for that, really. And all of you actually for yeah, making this happen and trusting us, trusting with your sensors and your data.
It was an interesting experience to have a quasi-online peer review process.
Yeah, you mentioned, Dobby, we should have recorded it and
Exactly.
included as a part of the peer review. And I'm getting a lot of comments just saying from people who participate in the exercises, saying the final and the biggest thanks to Toby for organizing this event and putting phenomenal amount of time, to Thanos to host and preparing many things inside. Of course, to Steve, preparing Quince to process so many varied data streams. And I think to the entire team and the core team at Vliz.
One more comment, Craig Anute from my side. Yeah, speechless again. Thank you.
Okay, thank you all again. So this is our second webinar. I think it is concluded now, and there will be a third webinar as Thanos Tobias advertised. There is no date set for that yet. It will happen sometime after the PIs and group meet in, I think we agreed in September, to discuss the results. And the third webinar would be in the form of a public forum where I guess the results will be presented to the scientific community, and the floor will be open for the discussion of results and online peer review process, let's call it that way. Other than that, I would like to thank everyone for your time today, and the recordings of these webinars will be posted soon. Keep an eye on the IOCCP newsletter and the website. And other than that, again, thanks to the core team of the exercise, and thanks everyone for attending the webinar today.
Thank you. Yes, thank you. See you in some month.
Yeah.